Hola, muy buenos días en América Latina
Hello,
y
good
buenas
morning in Latin
noches en
America,
China.
good evening in
Bienvenidos
China.
a este
Welcome
seminario
to this
Chino más
seminar,
Desarrollo
Chinese
Sustentable.
plus
Este
Sustainable
webinar será
Development.
impartido en
This
idioma
webinar will be
español,
given in
portugués,
Spanish,
chino e
Portuguese,
inglés.
Chinese, and
Pueden
English.
seleccionar su idioma
You
en la
can
parte
select your
inferior de
language
la
at the
pantalla
bottom of
donde
your
está
screen,
el mundo.
where you can see
Me
the globe
presento,
icon.
soy Roberto
I
Lafontaine,
am Roberto
director del
Lafontaine,
Centro de
Director
Cooperación
of the Center
Internacional
for
para
International
la Enseñanza de la
Cooperation for
Lengua
the
China,
Teaching of Chinese
Center for
Language,
Language Education and
or the Center for Language
Cooperation,
Education and Cooperation,
Oficina Regional para
in the
América
Regional
Latina y
Office
el
for Latin
Caribe.
America and the Caribbean.
Nuestro centro en América Latina y el
Our Center
Caribe
Latin
se
America and the
dedica a la
Caribbean
enseñanza
is
y
dedicated to the
promoción
teaching
del
and
idioma
promotion
chino entre
of Chinese
instituciones
language
públicas,
among
privadas,
public,
gobiernos
private
nacionales, gobiernos
institutions,
locales,
national, local
instituciones de educación
governments,
superior,
higher education
instituciones de
institutions,
educación secundaria y
secondary education
primaria.
institutions, and primary education institutions.
En esta ocasión, junto a
In this
los
session,
expertos
together
chinos y
with Chinese and
latinoamericanos,
Latin American experts,
exploraremos la
we will
intersección entre el
explore the
aprendizaje del
intersection
idioma
between
chino
Chinese
y el
language
desarrollo
learning
sustentable,
and
dos
sustainable
áreas de
development,
creciente
two
importancia
areas of
global.
growing global
El
importance.
desarrollo sustentable no es
Sustainable
solo una
development
meta
is not
ambiental,
only an
sino también
environmental
abarca
goal, but
dimensiones
it is
sociales y
also
económicas
something that
que
comprehends
son
economic and
cruciales
social
para un
dimensions that are
futuro
crucial
equilibrado y
for a
equitativo.
balanced and
En
equitable
este
future.
contexto,
In this
aprender
context,
chino y estar al
learning
tanto con
Chinese
la
and
actualidad
keeping up
china no
with
solo es
Chinese
una
current affairs,
oportunidad de
it's
enriquecimiento
not only
cultural y
an opportunity
personal,
for cultural and personal
sino también
enrichment,
una
but
herramienta
also a
estratégica
strategic
para
tool
acceder a nuevos
for accessing
conocimientos y
new knowledge
colaborar en
and
iniciativas
collaborating
globales
on
de
global sustainability initiatives.
sostenibilidad. Hoy analizaremos los
Today,
desafíos y
we will discuss
oportunidades
the
en esta
challenges and
área,
opportunities in this
especialmente
area,
en el marco de la
especially in the
colaboración
framework of international
internacional para el
collaboration for
desarrollo
sustainable
sostenible.
development.
Esperamos que podamos
We hope we
reflexionar
can
cómo
reflect on
el idioma
how
chino y la
Chinese
comprensión de la
language
cultura pueden abrir
proficiency and
puertas
understanding of
a,
Chinese culture
a
can open
investigaciones
doors
en
to joint
conjunto,
research,
proyectos innovadores
innovative
y un
projects,
entendimiento más
and a
profundo
deeper
sobre políticas y
understanding on the
tecnologías
policies and
entre
technologies
nuestras
that drive
regiones.
sustainable progress among both
Les
regions.
invitamos a participar
We invite
activamente
you
dejando
to
sus
actively
comentarios y
participate by
preguntas
leaving your
en la
comments and
sección
questions
de
in the
preguntas y
Q&A
respuestas.
section.
Este seminario será
This
grabado y
seminar
publicado
will
en
be
nuestro canal
recorded
YouTube
and posted
y
on our
todos los
YouTube channel,
participantes que
and all
asistan al
participants who
80%
attend
del
to
seminario
80% of the seminar
recibirán un
will
diploma de
receive a diploma
participación.
of participation.
Agradecemos su
We thank you
asistencia y le
for your
damos una
attendance and
calurosa
warmly
bienvenida
welcome
a este
you to
espacio de
this space
aprendizaje
for
y
learning
colaboración.
and collaboration.
Quiero hoy día,
Today,
antes de saludar al primer
before
expositor,
greeting the first presenter,
darles un saludo muy
I would like
afectuoso
to
de la
affectionately
señora Su
greet you
Yang,
by Madam Su
subdirectora
Mingyang,
china de la
Deputy
Fundación
Director
CLEC,
of
Oficina
the
Regional para
Clegg
América
Foundation
Latina y
Regional
el
Office for Latin
Caribe,
America and the
que
Caribbean.
ella está en
And
Beijing,
she is in
pero
Beijing,
no puede estar hoy día
but
con
she
nosotros
sadly
debido a que
cannot
tuvo
join
un
us today
problema de
because she had
último
a
minuto y les
last minute
manda a
issue.
todos un
And she
cordial
sends
saludo.
everyone some warm regards.
Voy a presentar ahora a nuestro primer
So
panelista,
now I will introduce
el
our first panel
profesor
member,
Ku Jiyun,
Professor Ku
profesor y
Jijun,
supervisor de doctorado de la Escuela de Ingeniería y
professor
Mecánica
and
y Almacenamiento y Transporte de
PhD
Petróleo y
supervisor of
Gas de la
School of Mechanical
Universidad del
Engineering
Petróleo
and
de
Oil and
China.
Gas Storage of Transportation for
Tras
China
recibir la
University of
maestría en
Petroleum. And
Ingeniería
after receiving an
Mecatrónica,
MS in
realizó su
degree in
doctorado en
mechatronic
Ingeniería
engineering in
Marina en la
2008, he
Universidad
completed his
Federal de Río de
PhD
Janeiro, en
degree in
Brasil.
marine engineering in the
Recibió
Federal
una beca
University of Rio de
completa
Janeiro,
del
Brazil. He
Consejo de
received a
Becas de
full
China y
scholarship
del
from the
Programa de
China Scholarship
Coordinación
Council
de
and the
Formación de Nivel
Coordination of
Superior,
Advanced Level
CAPES,
Training
del
Program,
gobierno
CAPES,
brasileño
of the
durante sus
Brazilian
estudios
government
de
during his
doctorado.
PhD studies.
Actualmente se
He
dedica a
is
la
currently
investigación de
engaged
diseño
in
estructural
research
y
on
equipos
structural design
petrolíferos,
and
diseño
petroleum
inteligente de
equipment,
realidad
virtual
virtual,
reality intelligent design,
desarrollo de instrumentos de medición
development
y control de
of
fondo de pozo e
downhole
inspección
measurements and
robótica.
control
Ha
instruments
completado
and
tres
robotic
megaproyectos
inspections. He has
especiales de
completed
China,
three
dos proyectos de
Chinese
la
special mega
Fundación
projects, two
Nacional de
National
Ciencias
Natural
Naturales
Science
de China
Foundation
y ha
of
publicado
China
más de
projects,
100
and has
artículos
published more than
académicos.
100 academic
Ha
papers.
ganado premios de
He has
progreso
won
científico y
scientific and
tecnológico
technological progress
de
awards
la
of China
Federación
Petroleum and
China de
Chemical Industry
Petróleo e
Federation,
Industria Química y sus
and
principales
his main
investigaciones
research
han sido sobre la
is
construcción
on the
inteligente de
intelligent
yacimientos
construction
petrolíferos
of
y
oil
tecnología de
fields
realidad
and
actual
virtual reality
modelo de
technology,
desarrollo de yacimientos
offshore
y gas en
oil
alta
and gas
mar,
field
diseños de
development
producción
models,
submarina,
subsea
robots de
production system
operaciones
designs,
especiales
petroleum special
petrolíferas,
operations
etc.
robots, inspection
Hoy,
robots,
el
among others.
profesor Ku
Today,
nos
Professor
presentará
Ku
el tema
will introduce
exploración y
the topic
práctica de las
exploration
sendas
and
del
practice of
desarrollo
China's
sustentable
sustainable
en China.
development path.
Bienvenido, profesor Ku.
Welcome, Professor Ku.
Okay, it's my great honor to receive the invitation of the GLEC to share this PowerPoint about the exploration and practice of China's sustainable development path. And the most important part, I work in the China University of the Petroleum, and for my doctorate degree in Brazil, and for the petroleum in China, I research in this subject, and I also research in the Brazil about the petroleum and with many cooperations with Brazil. And for China, I will give the 5 aspects to share with this. Is the first one is the inevitability of the take the path of sustainable development. And 3 reasons. The first one is a huge population pressure. And as we all know, in China's huge population as a first scale population, and now the first scale population is in India, and now at present the country has a population of the 1.41 billion, and also it in fact have an impact about for the life for the citizens, and the aging of the population has made the problem of social support for the elderly increasingly prominent. And with the statistics, by the end of the 2022, and there will be 209.78 million people aged 65 and over, accounting for the 15% of the total populations. And population and development in the poverty-stricken areas face serious challenges. And the task of improving the quality of the population is urgent and arduous, and is the first problem about the populations, and the second, and the shortage of the resources, and the first one is the water resources. And the problem of the water shortage is becoming increasingly serious. Per capita freshwater consumption is 2,330 cubic meters, equivalent to the 1/4 of the world average, more than 4 million square kilometers of the country's arable. And the shortage of all the fresh water, and the next is the and more than 1/3 countries, provinces, and autonomous regions, and less than 0.067 of the arable land per capita, and Guangdong, Zhejiang, and other provinces along the eastern seaboard. And the structures and contradiction between energy supply and demand has increased, with the energy consumption growing rapidly along with the economic growth, and there is a serious shortage, and the rate of the depletion of the large mineral reserves is much faster than the annual growth rates, and there is a serious waste of the resources. And the third is the deep environmental crisis. The sulfur dioxide emissions has increased, and the danger of the acid rains has worsened. And The national industrial solid waste generations reached autonomous in 2022, and the figure of reflects of the total amount of solid waste generated by industrial activities. And urban sewage discharge has increased substantially. And next, with the regard of the land degradation, China has an area of the 3.56 million square kilometers of the soil erosion, accounting for the 37% of the national territory and about 38% of the arable land subject. So in 1994, the State Council issued the white paper of the China's Agenda 21, China's population, environment, and development in the 21st century, which sets forth China's overall strategy and program of actions and implementations of sustainable development. And the most important part is to keep the populations and to develop the clean resources and consumptions and for the green economies. In this context of building an ecological civilization, China is actively developing a circular economy and a low-carbon economy suited to our national conditions and promoting the development of a green economy in China and to decrease the carbon dioxide emissions. And the differences is a circular economy focus on the resources and materials, low carbon economy focus on the energy. And the same part saves the resources and reduces water emissions and recycle material and energy. And for example, in the industry mode is a clean productions, and a clean production is a sustainable production and from the raw materials and to produce. In this process with three aspects. Is the first one is the clean energies and including the produce energy skills. And next is the process of the clean productions, including is we do not use and less to use the poisonous materials, and the clean products is have no any harm impact for this health and the environmental, and to reduce the raw materials and poisonous materials. And now a very important statistics is get rapid increase. And now for this fire power and industry, and for all the proportion up to the 95% in different clean produce resources industry. And next is ecological agriculture, and in agriculture we now to focus on the recycle strategies, and we put all the materials and use the different parts of these materials, like all the garments, to put all the garments to the another industry and use this like all the emissions can be used in different industry and to cooperate and recycled to different industries. It's the concept of the ecological. And next part, we use the petroleum or fossil. And now with the shift of the energies, we must use the new energies. And with some statistics,
其中化石燃料利用占了86%，土地呢
wind
利用占了
power and
我们全球一次能源消费
photovoltaic and usual in the best industrial development period in the process of energy transition, and more than 90% of new energy must be converted into electricity in order to apply it.
2020年呢，这个排放量达到了322亿吨，2021年是363，2022年已经达到368，整个是一个持续上升的过程。第三个呢，可以看到我们全球的温度、气温已经在升高了。
For the other
活动，全球地表温度在近50年
climate and the weather for the temperature of the climate is continually increasing, and from the last century up to this century, and
这个还是很明显的。
increased to the by the 1.1 degrees, and we must shift this of the screen. And now we must face many challenges for the energy shift, and now with the wind power, and more than 90% of the new energy must be converted into electricity. And wind power and photovoltaic is the main way to develop new energy. In 2021, China's renewable energy installed capacity of 134 million kilowatts of the new wind power and photovoltaic as new installed capacity accounted for 76.1% of the new installed capacity of the renewable. Hydrogen energy is a key development directions for the industry in the future. China is the largest hydrogen producing country. Its annual hydrogen production is about 33 million tons. Technology, innovations, and applications in the fields and hydrogen energy speed up the process.
这个地方，我们经常有大量的
in Xinjiang province,
我们也做一些煤制氢相关的一些这种研究。
is produce the and the research of the hydrogen researches.
我们的新型的储能这个技术必须要进行发展。
And a new type energy storage is an important technology and basic equipment to support the new type of power system.
得到了一些快速的发展。
Technological innovations such as the electrochemical energy shortage and the compressed air energy storage has made great progress since the 13th five-year plan. Lithium-ion batteries are the mainstream technology routes for the electrochemical energy storage. And CCUS is the main technological pathway to achieve the dual carbon target. And technological innovations in the field of the ocean energy are yet to be explored. High efficiency energy conversion technologies such as an ocean temperature difference energy, wave energy, and tide energy, offshore multi-energy, and complementations and comprehensive utilization of the deep sweater of the food, medicine, and healthcare products. And I mainly research as a petroleum of the oceans, and for the
为了这个可持续的发展，它做了哪些方面呢？第一呢，就是海上油气与新能源要一个协同发展。他们呢，打造海上油气田多人协采融合开发新模式，要形成水上、水面、水下
creates a new model and integrated development of multi-energy cooperative production of offshore oil and gas fields, and from the three-dimensional multi-energy cooperative and offshore plan water, surface, and underwater. And to constructing a new power energy for offshore and gas fields, build a new power system of offshore oil and gas fields that combine multi-energy complementations and organic combination of source, grids, load, and storage, and provide the foundation and integrated development in offshore oil and gas. This is a new energy. Third is technology empowerment promotes digital development of the energy industry. Operations, intelligent productions, integrated management and control, and scientific decision-making drive the low-carbon transformation of offshore oil and gas fields. The last one is offshore large-scale CCUS and ocean carbon sink. Offshore large-scale CCUS and ocean carbon sinks the guarantee. It is necessary to fully unleash the potential of the marine carbon storage and the marine carbon sinks and support its low carbon dioxide. And to realize the energy transformation practice and progresses of the China's offshore oil and gas energy the transformations. The first one is the coordinated development of offshore oil and gas and the new energy. Comprehensive energy system construction promotes the construction of the new energy. And to integrate the development with oil, gas, green integrated energy of Hezhou Island. Demonstrations. And next is integration of the decentralized with wind power with the production and cooperations, accelerate the decentralized the power of offshore isolated grids and gas. The third part is the combination and combined the deep sea wind power supply and hydrogen productions make full use of the existing oceans the energy.
电力系统啊，就是双碳目标啊，我们这个碳达峰、碳中和，我们这个能源转型和
next part is to construct a new power system for offshore oil and gas fields under the double carbon goals. And in Guangdong, Jiangsu, Fujian province,
我们分散式的一个海上风电与海洋油气田深度融合发展。
actively promotes the in-depth integrated development and decentralized offshore wind power and offshore of the gas fields.
电力系统互补的一个模式，实现了海上油田的一个绿色开发，就是它的一个可持续发展。另外呢，在攻关中远海风电关键
next part is the research key technologies of the COSCO wind power and seize the main battlefield of the future wind power constructions.
第三个呢，就是我们的中海油的油气
third part is technology empowerment to promote the digital development of the offshore gas energies.
油气田非常的多啊，中海油也建了很多，比如说 我们的深海1号、我们的秦皇岛等等，都是我们的中海油的制冷油田的一个代表和示范。聚焦呢是无人化操作。
To build a new oil and gas field explorations and development model, build intelligent oil fields.
场景与数字场景之间的实时交互，来实现我们的制冷油田的这样的一个精准的监控。
In the entire cycle, oil and gas field focus on the unmanned operations, visualize the revisers and coordinated operations and scientific making.
南海的我们是依托珠江口盆地4155亿的
The scale implementations of CCUS at sea on One South, One North offshore CCUS cluster. South China's CCUS cluster rely on the 415.5 billion tons storage in the potentials.
那么在环渤海的 CCUS 集群呢，我们依托于渤海湾的一个盆地的
And Bohai Sea CCUS cluster rely on the storage potential of the 287.8 billion tons in the Bohai Bay Basin, 3 clusters, and to become 1,001 north of offshore CCUS cluster. And for the, I mentioned the 4 parts, and we struggle for the energy transformations, and there is much work to do and to complicate the
和南美，特别是巴西在能源领域的一些合作和交流哈。我刚才也提到了
carbon dioxide. Just I mentioned, I get the doctorate degree in Brazil, so these two universities with many collaborations. And in 2007, CUS established and exchange relationships with the University of Rio de Janeiro, Brazil, which initiated collaborations between the university and the Brazilian side. In 2010, the 2 universities jointly established the Chinese Brazil Deepwater Underwater and Engineering Research Center. In 2018, Sinopec was awarded for 111 programs and for safety engineering of offshore oil and gas production with the China-Pakistan Joint Research Institute of the Deep Sea Technology. Since 2008, SU has sent a total of 52 times and 44 persons started at the University of Rio de Janeiro, Brazil, co-sponsored by the China's Brazil Deepwater Forum, which held in Beijing in 2016 and 2018 respectively, and the third one will be held in June 2024 in Shenzhen. Initiated establishment of the World Energy University Alliance 2018, including Russia, Norway, Canada. There are many universities to become this alliance. And CNOOC participates in the development of the deep water oil and gas resources in Brazil with a total of 5 active blocks. CNOOC Research Institute signed a joint research institute agreement with the Federal University of the Rio de Janeiro in Brazil and has approved the establishment and the CNOOC Brazil Energy Technology R&D Center. Tsinghua University has established a Sino-Latin American jointly laboratory for clean energy and climate change in cooperation with the Brazilian universities. So we opened many forums and China-Brazil Young Scientist Forum to renewable energy, climate change. And for this picture, and for the CCUS signed agreement with the Alliance in Brazil. As today's my sharing for others and why China should keep this path for renewable energy. And for this petroleum energy, especially for the CCUS, for the development and the progress for this petroleum and for this company of CCUS, not only in Latin America and in Africa, Canada, and North America. How all the audience and for all the participants can focus on this topic in the world and can join this industry. Thank you.
Okay, there we go. Thank you, Professor, for the explanation of the petroleum company, and especially the challenges that China has for a sustainable development. So without a doubt, as any country, we have our challenges, our problems, complications, but we need to work together so we can achieve it. Without a doubt, your experience and the work that you're doing is going to be most interesting for many members of the academia in Latin America, so we can contact and generate activities together. So now I'd like to lead you to the second presenter, Professor Luo Xun, Professor and International Project Manager of the National Virtual Reality Laboratory of China. He is the founder and co-director of Connected Universal Experience Labs, an international scientific and technological collaboration platform in Cali, Colombia, that was established in August 2019. Has carried out many joint research projects between China and Colombia. It has recruited more than 50 Latin American students to study in China on full scholarships. In 2024, it also established a Chinese Learning and Assessment Center in Cali in collaboration with the Santiago de Cali University. The center will starting with two classes of 30 students each in the fall of the semester of 2024. Today, he will be presenting the topic, Digital Twin Technology for International Collaborations in Biodiversity and Ecological Development. I would like to note that Professor Luo Xun is on a trip to Colombia and he's logging in from Korea. Thank you very much.
Thank you for Roberto, and it's my great honor to receive this invitations and to have this webinar, and thank you so much. We have many collaborations with Latin America, and today my topic is about the digital twins technology for the international biodiversity and green development collaborations. We use the skills of the metaverse vision, and we face the target face the biodiversity between China and the Latin America and the Caribbean. And in recent years, in the past of 2 years, for the metaverse vision, metaverse is the vision of the general public of commuting, and how to face the metaverse. So metaverse is a version of the general public. And for the metaverse, and the key point for the metaverse is the support by the technology and the innovations, and it will influence our lifestyles, and so in our daily life we can see because many different types, and we can use these skills to become a very immersed environmental and atmosphere, and how to keep contact between the metaverse vision and the realities, and we must use the skills of the digitalizations, and we use statistics and other skills to, and for all the parts they can evolve and to become a new personality. And if we create the new biodiversity, and you must keep all the animals, plants, and to keep equipped fish in genuine life, and if you can raise the fish in this metaverse, the vision life, it must the same with the realities, but if you can, it cannot enough to create a new biodiversity system. And in the past 5 years, we continue to research with Colombia and Ecuador and other ecologists of China to research this subject in Caribbean, as well many other tropical waters. In tropical waters is a full diversity of the animals, but in China, in Latin America and the Caribbean, mainly in the Caribbean and in Pacific, they also have the biodiversity. For example, in the offshore of the Peru, we know there are 4 main fish farm, including this Peru, and to become a very full diversities of the animals. And we pay more attention to in China, in the South Sea of China, because in the Pacific, in East Sea or Bohai Sea, and in some North Sea, for all the biology and the fisheries are increasing, and for the biodiversity has been harmed and ruined, and it's very rare in China for this past of years. But now for this fisheries development is now mainly for the deep seas in South Sea of China and in Latin America and the Caribbean are facing the common biodiversity problems. For example, the white of the corals, and because of the temperature of the sea and the quality of the sea, and people harmed for the coral. And besides this, and the degradations of the mangrove forest. In China, for the mangrove forest is for the poisonous. Besides of this, because of the corals and mangroves for many biologist habitats, and it's harmed by the people, and for all the biodiversity has been harmed. Actually, in China and in Caribbean, we are facing the same problems. For example, we use the common skills in Hainan province. In the deep water, we build the artificial farm yard, and we use the small scale corals and use all the small corals and to transplant it into the deep water, and it's the same as in Caribbean. In China, there is a project called the 1 million seeds. So we have these same ambitions. And for all the mangrove forest, we revive all the mangrove forest, and for the protections of the biodiversity and for all the policies, you must have the correct predictions, and we must make new policies, and it's very difficult. And next, and for the protections of the marine biodiversity, it's a long process. And for all citizens, if they know the scientific skills, and if they don't have the concept of all the protections, and another problems in China and Latin America is very far. It's a very far regions, and if the both parts and in a big scales protections and there are much barriers. There are many barriers of it, and it's related with to the other persons and for the policies and for the residents and all the common residents.
这当中有很多障碍。那么我们怎么来做呢？
of the
用数字技术来
regions and language barriers, we use the new skills to reduce the parts to reduce the influence of these two regions, and we use different process to balance it. For example, we use the digital for individual sea animals. For example, we use the fish to 3D modeling. We use fish and how to. And firstly, we make the shapes of the fish and choose the actions of the fish. And from this part, we can create a very genuine fish and use the regulations and habitats of the fish. We can conclude the regulations of the fish. We use all the regulations, put all the regulations into the fish. They can live in different environments, and we make the individual into the
还可能存在一些捕食关系，比如说有一些肉食性的鱼类，它会捕食小的鱼类。最后呢，我们把这样的结果呢放在栖息环境
collectivities. So we put these results into the habitats, including
温度的、盐分的海洋。我们把这些生物放进去以后呢，进行仿真，我们就能够
the
生成
oceans.
非常
We can
真实世界接近
create a very
生物多样性的
similar environment
那么
of
这
the
里呢，我们做了一些
biodiversity.
这个珊瑚礁鱼类的仿真啊，珊瑚礁鱼类呢，它是主要是小型的鱼类，那么它对于珊瑚
And
礁
for
的健
all
康
this
状况
digital
是一个非常好的指标。
technology to build a
那么我们
digital
会有多
bodies.
种行为，比如
So
说鱼类之间互相的吸引互相
for
的
the
跟
different
随
actions for the
比如说鱼
fish
类之间
and
互相的躲
these
避，
communications
还有
and
当有捕食的鱼类出现的时候，鱼群的一些行为，
how
我
to
们都做了
fish
非常这个接
for
近
these all the
于
actions
真实
for
情
all the
况的
different
仿
types
真。
of fish.
这样一来呢，
We
我们就能够
created
把鱼类的
an
个体和这个
artificial
群体呢
mode
都
and
能够
dimensions.
用数字孪生的方法来予以呈现。
So
那么这里呢，我们就展现了我们在这个加勒比海地区，就是在
and
哥
this
伦比
for
亚
in Caribbean region in
卡塔赫
Colombia
纳沿海的这个国家珊瑚公
and
园
the offshore
自然保
of
护区
this is in
我
the
们做的一个这个数字孪生系统。
National Park of Coron is a digital twins biosystems.
这个把这个知识放到了这个数字孪生里面，这样呢，这个公众他们就可以过来观看这样的数字孪生。那么刚才大家
Okay.
看到的这个呢，就
So
是
just now you can
在
say
哥伦比亚的
in
城市
Colombia
卡塔赫纳近海有一个这个国家
some
珊
close
瑚自然资源
says
公
there
园，
is a
叫
part of the
群岛公园。
corals
那么我们对
called
这
the
个
Lasaria
国家公园里面的
Islands Park,
生物多样性呢进行了数字孪
and
生，
we
这样的这个
research
管理者
and
和公
to
众就都能够很好的了解当前的生物多样性的情况，同时也可以制定相应的管理的
so we
政策
can。make the plans and policies for all the
那么我们除了这
biodiversities.
个海洋动物以外呢，
Besides for the marines and animals, we also do the research about the digital twins for the mangroves.
在植物生态系统当中呢，非常重要的一个就
In
是
the
红树林。
biosystems
其实还有一个
for
比
the
较重要的
plants,
生态系
the
统
main
就是
part
海
is
草
for
床。
mangroves.
比如说在中国的
And
广西
another
省，
is the
现
sea
在也
seed
正在进行海草床
in
的恢
Guangxi
复。
province. So
因
we
为在2
also
年以前呢，其实在海草床那边是
we
有海
also
牛
to
的，
recover
但
the
是
sea
现在呢，因为
seed
海草床的面积
habitats,
大面积
but
的
now
这个被破坏，所以在中国呢，海牛已经功能
because
性的
of
灭
the
绝。
damage
但
of the
现在又有
species
野
of
生的海
habitat,
牛。那现在要引进这个野生海牛呢，首先要恢复这个生态环境。 那么红树林也是一样的，红树林它里面的鱼类、鸟类，还有像螃蟹啊这些，其
Now
实
there
都
is
依赖于红树林的环境。
there isn't the
那么
wild
我们怎么来对
manatees.
这个红树林进行保护呢？其实
Then
也
how
可
to
以通过构建
protect
数字孪生，因为
the
现在呢，它的这个数据
mangroves?
的
And
采
now
集
we
比
can
原来
also
要方便得多。
also use
也
the
就是现在
digital
通过这
twins.
个卫星的
Now
遥
through
感
the
就可以
satellite
非常
skills,
频繁的获取到
we
红树
can
林的生存状况。
frequently to
那么我们把这些生存状
obtain
况的数据呢，
the
输入
statement
到
of the
这个数
mangroves,
字
and
孪
we
生的
put
模
all the
型，我们就能
statistics
够获得
into
红树林
this
的数字孪
artificial
生的效
mode.
果。
We can
那
obtain
么这里
the
呢，我们用
result
了
of
一些
the
这个计算的方法来对红树林进行计算。我们知道红树呢，其实它是有很多种类别的，大概有将近20种。
There's
那么我
many
们
types
在
of the
中国的海南
mangroves,
省
almost
对这个
20
20
types
种的红
in
树
Hainan
和
province.
海水
We
的盐度
research
和这个潮
these
汐的强度
20 mangroves
等等，我们都进行
and
了
we
这个数字化的仿真，然后这样呢，
do
我
the
们就能够
digital
生成非
twins
常
to
真实的这个
do
红
this
树。
artificial
那
research
么这个红
in
树呢，我
Hainan
们
province.
在结合
And
当地的一些环境呢，我们就能够生成红树的树林。大家也可以看到，就是在右下角这个视频里头，是我们仿真在
in
海南
this
省的沿
video,
海
you can
红树的一个生长，同时和卫
in
星
Hainan province, you
遥
can
感
see
所获得
the
的数据呢互相对照，我们就能够生成非常真实的红树林。那么还有
you can
呢，
see
就
the
是
growth of
海
the
水
mangroves
的这个
and
水
other
质。
other types. And
其实
for the
有一个很
qualities
重要
of
的
the
指标，
sea
就是在这个里
as
面
a
的
very
软体动物，或者说我们常
important
说的贝壳生长得怎么
standards.
样。
And for
而且
all
贝
the
壳的形
shells
态呢，也能够反映当地的
and
这
for
个
the shapes of the
生态系
sea
统的一个健康
shells,
程度。那么
it
我
can
们用数字孪
reflect
生的方法呢，对
for the
中
health
国
of the
的南海，
habitats.
还有加勒比海沿
And we
岸
do this
常见的一
research for the
些
South Sea of China
软体
and
动
in
物类，就
Caribbean
是贝
seas.
壳类，我们做了数字孪生的计算。那么这
We
些
do
呢，
the
然后我
digital
们结
twins to
合
collect of the
在
seashells in
中国
South
的南
Sea
海
of
和
China
东海岸
and
采集的
Caribbean
这个贝壳的实
to
际的标
collect
本，我们用 CT 扫
the
描的方法
samples
获
of the
得数据，
seashells
这些数
and
据呢
use the
就过来
CT scan to gather
推测
data
我们仿真
for
的
slice
效果。
and then
那么
fitting
这样呢，我们就能够
parameters
非常
to 3D
好的获
constructions.
取到这些
And
沿
it's
海
better
和
to
海
get
水的质量，以及当地的一个
the
生态
qualities of the
生物多样性的一个健康状
seas
况。通过这些
and
贝壳的分
know
析。
the
好，那么
biodiversities
最后呢，我
of the
们来
sediments
说一
of
下
the
就是珊瑚。
habitats.
珊
And
瑚
the
呢，它其实是
last part for
在
for
生物多
the
样性领域，大家经常用
stagnant
珊瑚来
corals
做这个例子。
in
它有很多原因。
biodiversity, we
第一呢，
also
珊瑚
take
非常美
this
丽，
for example,
大家看到
and
珊
it's
瑚的时
very
候
beautiful.
都非常感
And
叹
when
大
we
自然
see
的美，
this
也就自然的产
stagnant
生了去保
corals,
护自然界当中的生物多样性的这么一
it
个想
can
法。
make us to
还有一个
protect
呢，就
these
是珊
beautiful
瑚所
plants.
形成的
And
这
the
珊瑚
next
礁呢，
reasons
在海
and
洋里面
for
是非常重
all
要的
these
其他
corals
海洋生物的栖息环境。那么对于
is a
一个
very
健康的
important habitat for
活跃
other
的珊瑚礁，就能够维持一个非常健康活跃的海洋生
for
态系统。
other
就
fish
好
and for
像健
other
康和活跃的森林里面就有
biology.
多种多样的鸟和其他动物一样。那么珊瑚呢，这些年破坏很多，我们和这
In
个
this
生物
past
学
of
家一
years,
起合作，
the
也是使用
the
数字技术，
stagnant
我们对
corals
珊瑚来进行这个计算，我们就能够对大概10多种珊瑚吧，现在都能够做很精准的这个计算，尤其是
we can
在
collect for more
加勒
than
比海地
10
区的一些常见
types
的
of the
珊瑚，
stagnant
现在我们
corals
都
to
已经能够给
simulations
出
and the results,
卫星测
and
量
we
的
can
海
give
水
the
的温度以及这
give
个海
the
水的一些取样的数
accurate
据，我们都可以
temperature
预
and
测
the
出
qualities
珊
of
瑚
the
会长
sea,
得怎么样。那么这个技
and
术还
we
是
can
很重要的，
predict
因为
the growth
我
of
们知
the
道就是在
corals.
海底建这个珊瑚苗圃
In deep water, if we
它的
build
数量
the
是非常大的，它大概
habitat for the
有
corals,
成百
is
上千个珊瑚的
it
这
must
个
be a
幼
big
苗，然后
scarce
用这些
for
幼苗去
this
生长了以后呢，把它移植到海里面去。那如果在这个生长和移
and
植之
we
前，我们就能够做很好的
transmit
预测
this
呢，
all of the
我们就
corals
能够
into
大
the
大的
deep
提
water,
高
and we can
珊
predict
瑚幼苗育
and
苗的这
can
么一个效率。
to
所以这个工作
promote
呢，我
and
们做了一个
improve
还是非常有用，就是在中国的海南省，
the
还有
results
在
of
哥伦
the
比亚的珊瑚国家公园，我们现在都已经在应
stagnant
用
corals.
这些技术。那么我们可以看到一些仿真的效果，
As
就是
we can
这
see
里呢
is
就是
for
大家可以
all
看
the
到，常见的这个珊瑚呢， 它每年生长大概是不到10厘米。
All the
我们
simulated
要
effects
能够构建到珊瑚礁的珊瑚，
s-
持续的观察呢，至少
so
要
that we
10年以
can
上。
create
那么现在呢，我们用数字孪生的技术呢，
for the
能够非常
habitat of the
准确地预测
corals
出
and
这个
we can
在对
accurately
生态
to
环境进行保护的情况下，
predict
那么珊瑚能
for
长到什么样
all
的情况。
the
左边呢是这个
growth
珊瑚
all
长
the
出的情
corals
况，
growth
右边呢我们因为可
and
以
for the
预测
right
说，
part we
如
can
果形
predict
成了一定的珊瑚礁
if
规模以后，
become
会产生什么样的
some scales for
鱼类
these
的聚
corals
集。那么我们
and
用这个
to
方法呢，在中国
how
的
to
海南省
become
进行了预
to
测，
the gatherings
就
of
是
the
预测
fish
这个
and we
巨
predict
型
in
的
the south
珊
of the
瑚
sea
什么时候
for
会出现。那么我们的这个预测也
for
是
the
非常准
giant
确的。我们
fishes
在
and
之前的
how
预测呢，我
what
们
time
预
to
测随着
appears
这个
in
珊瑚
this
礁的修复
habitat
呢，在海南的中国海
yeah,
南
with
省
with the
3月
revive for
在
all the
今年
habitat
的
for the
9月份之
corals
前
in
会
Hainan
出现巨
province
型石斑鱼。
in the
那么
before September
今年的
of
5月
this
份呢，
year and it
我们
must
就已经观测到巨型石斑鱼的
appears
出现，
for
所
the
以
giant
数字孪
fish
生技术还是发挥了很好的作用。那么现在呢，这些在
and now
中国的应用呢，是在中国的海南省。海南省是中国热带海洋
these
面积最大的
skills
一个省。那么
is
现在呢，用这个
mainly
技
used
术
in
呢，做
Hainan
这个珊瑚
province
礁的恢复。然后在中国的广西省呢，用我们的这个技术呢来做这个
as a
海草
management
床的恢
agency
复。
uses
刚才
the
我们介绍了，
DT
就是海草
system
床的
for
恢
the
复呢，
coral
其实是
reefs
海螺
restorations
回归的
in
一个
Guangxi
重要的前
province,
提条件。
China.
然后在
For
哥伦比
this
亚呢，
DT
也
system
是
for
在这个
seagrass bed
萨瑞
restorations
这个国家珊瑚公
in
园，我
Colombia,
们在用这
Rosarios
个
Islands
我
Natural
们的这个
Coral
数字孪
National
生技术
Parks
呢，
of
来
Colombia
做这个
adopt
珊瑚礁的
use this
管理
system for the
和珊瑚
coral
恢复
management
的
and
预测。
predictions.
那么在今年10月份，就是
And
联合国的
in
生物多样性
December
大
of the
会
today, and for the
COP26
forum
是在哥伦比亚的卡利
of
来
the
开，那么我们也会展
biodiversity
示我
UN
们的相关的这个技术。
and in Caris
好的，
of
谢谢，这
Colombia
就
will
是
also will
那
show
个
our
我介
these
绍的一些我们的
skills
相关的一
for
些
all
工作。
the audience.
Muchas gracias, profesor Luoshun, y sobre
Thank you
todo
very
por
much, Professor
hacer este
Lushun,
esfuerzo de
and especially for
conectarse
making this effort
desde
of logging in
Corea y
from
su viaje a
Korea
Colombia.
on
Muchas
your trip
gracias, ha sido
to
muy
Colombia. Thank you
interesante
so
su
much. It has been
presentación y
most
sin duda
interesting, your
alguna
presentation.
nos ofrece también la
And without
oportunidad
a
de
doubt,
poder
it also
colaborar
offers us the
entre
possibility of
académicos latinoamericanos.
collaborating and having Latin
Y ahora
American
vamos a pasar a los
faculty as well. So now
académicos
we'll go
latinoamericanos
to
precisamente.
the
Quiero
Latin American
presentar a
presenters. So I
ustedes
would
al
like to introduce
profesor
you to
Francisco
Professor
Belmar,
Francisco Belmar.
ingeniero civil
He is a
industrial de la
civil industrial
Pontificia
engineer
Universidad
from the
Católica de
Catholic
Chile,
University of Chile
además de contar con un
and
magíster en
has a
matemáticas
master's
de
degree
hidrógeno en la
in
misma
hydrogen
universidad.
mathematics
Es
of the
profesor
same
adjunto de la
university.
Escuela de
He's an associate
Ingeniería
professor of the
y
UC School
jefe
of
de proyectos
Engineering
de la Unidad de
and
Tecnologías del
project manager
Hidrógeno.
of the Hydrogen Technologies
Recientemente ha
Unit. He has
participado en el
recently
desarrollo de
participated in the
estrategias
development
de
of the
descarbonización
decarbonization
para empresas
strategies
logísticas,
for
como
logistics
también en el
companies, as
análisis
well
de
as in the
diversificación
analysis
de la
of
matriz
diversification
energética de
of the
regiones
energy
de Chile.
matrix of
El
Chilean
profesor
regions.
Belmar hoy
Professor
nos
Belmar
presentará el tema
today will be
Estatus y
talking to us about the
desafíos
status
de
and
la
challenges
industria
of
del
the
hidrógeno.
hydrogen
Muchas
industry.
gracias,
So thank
Francisco, por
you
estar
very
con
much,
nosotros hoy día.
Francisco, for being with us today.
Muchas gracias, Roberto, por
Thank
la
you very much,
introducción.
Roberto, for the kind introduction.
Ahí ya debería verse mi pantalla
You
Sí,
should be able to see my screen
fantástica.
already. Brilliant.
Para comentarles brevemente
So
respecto
briefly,
a quiénes somos
regarding
nosotros, la
who we
Unidad de
are,
Tecnología del Hidrógeno es un grupo
the
de
Hydrogen
profesores
Technological Unit is a
que se
group of
aloja
professors
dentro
that
de
is hosted
la
within
Universidad Católica,
the Catholic University,
en la cual nosotros hemos desarrollado
where
distintas
we have
líneas de
developed
trabajo.
different lines of work.
Participamos, por ejemplo, en temas
We
normativos en
participate
el país,
in
donde
topics regarding
realizamos
some
la primera
standards
propuesta
in the country,
normativa para el
where we did
hidrógeno
the
verde en
same,
Chile.
we did the first
Naturalmente,
proposal for Chilean standards
también
for
como
hydrogen.
profesores
Naturally, since
participamos
we're
en
also
investigación,
professors, we
hemos
participate in
hecho estudios
research.
relacionados con el
We
uso de
have
materiales
conducted studies with the
microporosos,
related
almacenamiento del hidrógeno y
to the
también
to
análisis
the
respecto a una de las
microporous materials
particularidades
for
muy grandes que
storage
tiene
of
Chile, que es
hydrogen.
el
And
uso del
also
hidrógeno
one very interesting
para
thing
la gran minería del cobre.
is
¿Sí? Hemos
another
trabajado también en
interesting
algunos
use that we have is
consorcios
the use of hydrogen
para la
for copper
combustión
mining.
dual
We have some
de hidrógeno
consortiums
basado
associated to the
en
dual
diésel.
um,
En los
conduction of
últimos
hydrogen and
tiempos,
diesel.
en lo que nosotros
Lately,
hemos estado
Where we have been focusing with greater effort is to try to work from the university and connect with the industry. So we have tried to leave the lab so we can focus on how can we contribute with value from the universities to the challenges that the industry is seeing. So one of the things where we have worked on, for instance, is a roadmap for decarbonization for leading companies in transport and logistics for foods in Chile. We've also been working on the analysis of the use of hydrogen channels, understanding that the reality that we have in Chile, based on what they have in China, is very different. In China today, we have full cities that have great fleets of hydrogen-powered vehicles. In Chile, we only have a few, and we have 3 hydrogen cars and 1 bus. So we are very delayed in terms of the technology that you possess currently. So the challenge that companies have in the country is also to be able to understand how can we introduce this technology. I believe this is the type of questions that people were asking themselves in China 4 or 5 years ago, and these are the questions that we are answering now. Also, we have in our intentions to be a contribution to the discussion in public policy. Understanding also that what happens in Chile is that we have a great trust regarding the educational institutions that we have in the country. In fact, universities in general show up in the rankings of reliability by the citizenships in very high positions. So therefore, we have great reliance in universities as a valid speaker in topics that can be very complex, such as the deployment of green hydrogen industry, giving some topics that we will be discussing later in this session. So we have an observatory for the development of green hydrogen, where we gather and meet the communities where today we are seeing most of the hydrogen projects in the country, and they are located in the north part of the country mostly because of the high radiation that we have, and also in the southern area, more specifically because of the quality of the wind that we have in the Magallanes region. Additionally, we also developed an explorer of green hydrogen, which you can see on the right-hand side. It's an interface that we can also share the links for, and this is a living tool where the users can access to this tool and calculate the level cost of hydrogen, the production cost of producing 1 kilogram of hydrogen. So this is based on different parameters that the users can obtain. And the advantage that this tool has is that this is a free of access tool. It was co-developed together with the Ministry of Energy, and also it is linked with databases that are very robust that the state currently has. And these databases have associated information to the generation of solar energy as well as the generation of wind energy. So we mix these databases for solar resources, wind resources, so we can give life to these hydrogen explorer. So we also promote the interministry agreement for the implementation of the hydrogen bus in Santiago. As I was saying, we are still at early stages of hydrogen development in Chile, and we could set the first stone or maybe the first idea. We set the first idea rolling in order to promote this agreement. And in the pictures that you see here is 3 ministers of the Chilean government, Maisa Rojas from the Ministry of the Environment, Minister Juan Carlos Muñoz of the Ministry of Transport, and Diego Pardo from the Minister of Energy. So we could bring together from our position of as a university, we can join visions from the state and the private sector, so these projects can become a reality. And their idea is that this bus can be used this year. In the latest information available to me now is that the purchase order had already been sent out, so we can import this bus this year. Also, we accompany in the process of training. We have close to 1,000 people that have gone through different levels of training with us. We do pre-graduate classes and also at a level of the diploma work, and we have achieved about 1,000 people in the different educational programs. I'm now going to go into the hydrogen itself part of my presentation. It's just a couple of slides. And we already talked briefly about this in the previous presentations regarding the challenges that we see and how hydrogen makes sense within our energy grid. So what you see here on the chart on the left-hand side, and then you have years and then energy consumed on the y-axis. So we can see two trends. First, we have a trend, a very strong trend related to the use of fossil fuels. You can notice that most fuels come from natural gas, oil, and coal. And then we have a very small fraction, which is sun and wind energy. So that's the first trend. The second trend that we see is the growth of this line. Not only we need to see the proportion of each one of the fuels, but also how this trend is growing in time. So what this tells us, this chart tells us, is that we will continue using more energy, and given the proportion that we currently have, most likely that energy in the future will be coming from fossil fuels. So the challenge is, that was also commented some slides ago by some presenters, is how can we remove the fossil sources given the effect they have on the planet and the temperatures, given the greenhouse effect that is generated by CO2. So there are several alternatives to try to fight climate change. I put the level cost of the energy from solar energy in yellow or wind energy in blue, and we can see that we have an important decrease in cost, which has allowed that we can deploy a greater amount of energy at a world level. So now we have a very strong alliance between Chile and China. China is the country with the most solar energy that has in its energy grid, but Chile, in percentage terms of our energy consumption, is the #1 country that has the most solar energy proportional to their total grid. So we have about 20% of our energy grid comes from solar energy. Now, we have certain uses where solar energy or wind energy or any other renewable energy is not going to be enough. For instance, it is not going to be easy to fuel a plane with solar panels, or it's not going to be easy to have a ship that will go across the seas with wind energy as it was done several years back. So what we need is to find a way, how can we store this energy in the sun or the energy that comes from wind? How can we store it so we can use it in different use possibilities where these primary solutions are not available? So hydrogen, together with other alternatives such as batteries, is positioning itself as an alternative that could be quite interesting to take into account in order to reduce the emissions in the planet. So here, just as general knowledge, we have many ways of producing hydrogen. If you remember the equations of natural gas, is basically methane, one molecule of carbon, one hydrogen. I could extract it. The disadvantage this has is that I obtain hydrogen, but then I generate CO2. But generally speaking, we color-coded the hydrogens so we can identify the different sources of hydrogen. So we have gray hydrogen, which is the one coming from natural gas or from carbon coal gasification or natural gas reforming. Blue is the same process, but I capture CO2. So these capture CO2, I store it, or I can use this CO2 in other processes, and with that I can reduce in 95% the emissions. Green hydrogen is different. I don't longer have natural gas. I don't have carbon or coal. But in the case of green hydrogen, what I do is I produce renewable energy through sun or wind, and what I do is to separate the water molecule, which is H2O. So I produce hydrogen from water, and renewable energy. Then we also have other colors, such as pink hydrogen, which is the same thing, but the source is not renewable, but it's nuclear energy. So if you look on the internet, the different colors of hydrogen, all of this coding is open even more. You have yellow hydrogen, white hydrogen, brown hydrogen, all sorts of colors. But these are the main colors of hydrogen and the main coatings that we have. So if you Google that, you will find 10,000 different colors of hydrogen. And then it really depends on your criteria to see whether or not they use a few or many colors for this name. So one of the advantages that hydrogen has is that there's already a market for it. It's not a new thing. What is new today is the way in which we produce hydrogen. And in this chart on the left-hand side, we see how we produce hydrogen. And on the right-hand side, we have how it is used. So here you can see that most hydrogen is produced today with natural gas and a fraction with coal. So a very small fraction, which is this yellow line here, is the one produced from green hydrogen. And where is hydrogen consumed? There's refining processes, ammonia processes, methanol, and other uses. So you could say that one of the advantages that hydrogen has, green hydrogen in that case, I could just replace this hydrogen being produced here, and I can turn it into green, and therefore already have an existing demand, which is a very large demand. We're talking about 210 million of hydrogen tons per year. So what is happening regarding the industry with green hydrogen? Again, I would like to remind you that we have tried to position ourselves from the university as a relevant stakeholder to push and accelerate the deployment of this technology. What we can see now, globally speaking, is that we have a small fraction of projects that are the ones that effectively are in an advanced stage where we have already committed the investments. All of these projects here don't necessarily mean they will materialize. It's just this fraction here. So therefore, we have a lower proportion of projects that will be materialized. We just have 7%. Prior to that, we explain here that because worldwide we realized that the expectations of cost reductions are not going to be as simple as we thought. In 2019, the International Agency for Energy developed this map where we can see how some countries can reach one cost of hydrogen that are lower than $1.6. And you can see here, Chile, the Antofagasta region in the northern part of Chile, or in the south, because of the wind, we would be able to achieve producing hydrogen to less than $1.6. However, what we have noticed is that what has ended up happening is that the cost expectation is greater. So if before, for 1 point, we were talking about an estimated cost of $2.9 per kilogram, that point will not be able to produce to 2.9, but $5. And why is that? Because we have had an increase of capital, capex, electricity costs are very meaningful, and also the funding, which has been a phenomenon that has affected different industries, given the current inflationary scenario that we can see worldwide. So we did the same analysis in the Magallanes region in the south of Chile, because in Chile, we had some expectations that by 2050, we would reach a price of hydrogen to $1 per kilogram of hydrogen. However, we started checking those data because we saw they were very optimistic. And what we did was to analyze how much do we really see when we start getting more variables in, such as the degradation of the electrolyzer or the complexities that we have in the operation and such. We did an analysis of how much could that cost be. So, well, we come to this part when the gray bands that we see here between the conservative scenario and the optimistic scenario, this gray band would reach to would touch the national strategy. It's even overlapping is very optimistic. So this is very favorable conditions. So we believe that this will not happen, or it would very hardly happen. And we believe we will be more between 2 to 2.5 US dollars per kilogram, which in terms of dollars does not seem a lot to go from 1 to 2, but in percentual terms, we're talking about double the cost of hydrogen. So we have also tried to position ourselves, given that there's some trust in the institutions such as university, we position ourselves as a player that provides relevant inputs. This was work that we did for the government, so the government can also understand in a better way what are effectively the costs that we can expect. Locally speaking, we also have some challenges for developing these type of projects. We have some topics associated to permits. We have some social environmental aspects that need to be addressed, because we do have this questioning associated to green hydrogen of how green is it really, and what is the impact on the territories associated to the deployment of the technology, the water used for desalinated water, and also these projects that are particularly in Chile for the southern area. They're very sensitive because these are areas where previously there was not an industry. So now there's a large industry coming in, where we have foreseen even we could have an installation of 10 gigawatts or 20 gigawatts of wind energy, equivalent to 1,000 wind turbines, and which has also caused a level of concern by the communities when they see this large number of air generators located in an area that previously had no industry whatsoever. So that is what I had to comment for you. It's very brief, and this is regarding what we're doing and the challenges that we see in the deployment of this industry. Then we're open for all of your questions that you may be having. Thank you very much. Thank you very much, Francisco. It has been very interesting to especially know the differences between hydrogens, the types of hydrogens, regarding the colors, as you were explaining, and what is being used here in Chile. The challenges, you spoke a lot. We have been speaking a lot in Chile about the potential of producing green hydrogen and exporting it. Without a doubt, this is one of the biggest alternatives for the future in terms of energy. So therefore, we'd really like to thank you for your presentation. And I'm sure many people will be very interested in what you're doing and what is being done in China together with other Latin American members of the academia that we have seen here. So, and now, to introduce the last presenter, last but not least, Dr. Rodrigo Barraza, civil industrial engineer from Universidad Técnica Federico Santa Maria of Chile, Masters in Business Management of the same university, has extensive experience both in the leadership of technological projects as well as in business management and contract administration at a national and international level. He is a full-time professor in the School of Engineering of the Santo Tomas University of Chile. He develops a line of research on design for sustainable operations in the PhD program in engineering sciences, mentioned in industrial engineering at the University of Santiago de Chile. In the academic field, he has worked as a professor in the master's program in different universities, and he's also a specialized advisor in the national direction of the development of INACAP. And he will present the topic today, Chinese language and sustainable development in Latin America. Thank you very much, Rodrigo, for being here. And of course, I would like to highlight something that's very important by Rodrigo. He made a Sustainable Americas Congress that came from networking. This came from a networking of Latin American professor, and this is already entering its third version with several parties participating from all of the region. Thank you very much, Rodrigo. Thank you very much, Roberto, for your kind introduction. I'm going to start presenting now. Perfect. So what I would like to comment now is that I really thank you for for the opportunity. Now that we're going to turn to an aspect of sustainability that adds a social component. While work and research that we do was the optimization of supply networks, the objective was always to work on supply networks for communities or small producers. So here we have a reference here. We need to highlight how it has been going through in time, how we have seen all of the supply chains for production. So we can see several aspects. Today, as professors presented before, I'm not going to dwell on that further, but the temperature of the planet, the growth of the population, and the technology are very important factors that we need to incorporate in the work models. And how do we relate among each other? So here we have the navigation chart that is proposed by the UN with the SDGs. And in this research work, we're going to be focusing on SDG 9 and SDG 12 of the industry and infrastructure and the responsible use and consumption. So, however, the activities that we do of getting involved with the environment and the community will always be activating other objectives. So they have a result that also helps the general progress of all of the objectives. So let's go to our topic. So our proposal here is to start finding opportunities in the closed loops of supply. While circular loops on circular economy, sustainable circular economy, are earlier from for a long time already, industries and people have been repairing and reusing items so we can progress. However, the focus was always in minimizing production costs, and now we need to take a new look to this, which is a new challenge, as it was proposed by the professors here in this case, in the industrial production networks. And the challenge is going to be on how can I have an impact in the collection and the final disposition of these items. And if I want to go to a higher performance level, how can I maximize the value of each one of the stages of the life cycle that the product has? And here, there's something very important. We have a link at the bottom if you want to see the source, which is the economic complexity overview of countries. And in the case of exports from China, we see how they have positioned themselves in the world as electric car producers and producers of batteries and producers of solutions for electromobility, complete solutions, that is. And in the same way, in Chile, we have this other aspect looking at the same from the point of view of our countries. China is one of our first customers, and our exports go there mostly. So, as it was said before, Francisco, what can we offer? We have a high potential of solar radiation, and we can offer also our minerals. I'm not going to be referring to the power or other things, but mostly I want to speak about the development of this research. And as a context, we have small mining in Chile, which has an impact of the of the GDP or the wealth of the country, which is less than 1%, but that it generates a big amount of employability, not only in Chile, but this type of small mining and artisan mining, we see these throughout the Andes, both in Chile, Peru, and even Ecuador as well, going on to the Argentinian side and Bolivia, and also towards Brazil. So we have a number of communities for small mining that depend on the production and the extraction of ore. This work was also requested by the Chilean government. From the partners that ENAMI has, we group 527 small mining installations. They have more than 2,000 partners in general, but the problem they had was as follows. The problem was that, in fact, if you see this, we have a curve that shows the price of copper and the price of copper from 2016. We see that it's going up. However, the amount of small miners was going down, and the sales of ENAMI were going down as well. ENAMI goes out of business in 2021 and 2022. But the issue is, how can we reverse this trend of, despite having a high price, it is not appealing for small miners or artisan miners to produce this. So it is more appealing for them to do other source of incomes or be in other businesses rather than do mining exploitation in a small scale. So here we have a challenge, and then we ask the question: how can we use the system of subsidies or funding that aids these small communities? And one of the issues here was the great cost of production that they have is regarding the moving ore, basically moving rocks around from one place to another. So then we get a question, a research question, which is, where can we put a intermediate point of purchase for the supply network that has sustainable features, that basically addresses the process and can improve the conditions of these small mining projects. So I'll skip some of my slides, but if you see here, we had an effort of analysis of the literature so we could define what were the critical factors in the mining sector and the energy sector, because the mining sector is very demanding of the energy that they need in order to extract the ore. And then we are left finally with 9 factors: the quality of the service, delivery time, the long terms of waiting, the efficient collection, global scaling of the business, retrieval mechanisms, inventory policies. How are we going to be controlling the stocks, and the optimizations of the models and resilient systems, so that the system were capable of self-help themselves and basically bring prices to a good position given the variation of the business. When prices go down, miners stop producing. Therefore, we need to find a factor that can promote the production. So we set up a flow so we can obtain so we can get a global idea of what is the value generated by this network of producers. And regarding these parameters, we have a mixture of hierarchization algorithms. And we had an optimization model, a lot of maths here, and the model looks like this in the end. And What do we mean? Basically, the situation that we had before was what we're showing here on this chart. We have small mining suppliers, about 527, and only 4 processing plants that are the ones that receive the ore so they can trade it. And here we have the other network. So our proposal is to include these hubs, these intermediate points, so small mining suppliers can just make the effort of getting as far as this intermediate point, and the movement towards the processing plants is then by the state or as part of a subsidy or the benefit in a way that we can support the integration of production. So here's the criteria. If you pay attention here, within the mathematical model, we added the 9 criteria we were recently mentioning. They go into a matrix, and then we develop the fusion of objectives so we can achieve the value. What do we have here? So this is the map of density for small miners, and we managed to turn them into this link here. And this is the report that ENAP kept, so we could analyze what is the situation of the quantity, not the prices, but the quantities of resources and sites that are integrated in the country, and they can go and do this in a more dynamic way in the update of the database and having an idea of how can we characterize this small mining supplier. I'll go faster now. So here we have the solutions, and we can identify new locations for these intermediate points of purchase. And what is interesting here in these types of models? First, it is possible to measure the benefits for groups. So usually the literature explain to us the solution for a company, for one case, and now, as it was shown just now by the professor, where I can group and have the results for networks. It is very interesting now to see how the total network behaves. Also, from our perspective as well, the carbon footprint measurements are considered as taxes. So oftentimes they become a barrier, an entry barrier for markets. And the other thing is to say that it is feasible to combine methods and we can do territorial management. So that is important. How can we contribute for a small community without solution? The same model is being applied in Colombia, Medellin, in Antioquia. We have a number of networks of producers of flowers. They produce plants and they export them. So the same model, same equation, and we are doing some improvements here, but it's useful to all the types of associations of producers. And what I would like to present now is that we have operation bands. So the sustainability in the production processes requires a level of investment that is such that the operation costs or the mean costs that we would have maybe should not be as high. So I have to say that, okay, I'm not going to be making this change. I am not going to paint myself green. I'm not going to be sustainable. And therefore, there's also a range where you can optimize this and where it does make sense and where you have maximum values and where we can be sustainable. So this is an example, a simple one. This is like soccer, as the Eurocup. So if a national team goes and play the Latin American Cup and they win, most likely they will come back and all of the other soccer teams will get better. The same thing here. If some companies make decisions and they invest in green technology, the network benefits as a whole, the complexity of the network as a whole becomes better. At a level of universities, we have Francisco and Catholic University. If they publish, if they gain a patent or they get awards, all of the other universities that are conducting research and maybe have not published, they don't have awards, will also get better. So the whole network will improve. And this is a factor of incentives that is very interesting to promote the analysis in the network of the impact that sustainability has. As a last message now, regarding the impact factors that we saw and the technical factors that impact the productive processes and the development of networks, after years and years in the work with the government and with private companies, in research, etc., we realize that we have other factors as well that are not just technical. We have ethical, emotional factors, and human factors that allow us to develop these links that the professors were commenting just now. The academia is the factor. So we need to continue developing these type of instances that allow us to generate a link here and opportunities for contact and of sharing our experiences in a way that we can contribute. Because otherwise we can bring students back and forth. If we can't get students from China and do an exchange with students here, but the same for professors, there's a huge challenge regarding academic mobility and promote this as well, because I put here the example of Ignacio Muñoz as a student of engineering that is now in Hanfei in China. And here in the background, he will have the experience of the Chinese language, etc. But the most important thing here is that he should be able to know the culture, know the values, and put that into contrast and see what do we have in common after all this. Sometimes you realize you have more in common than what you have of differences. And with that, I would like to close this and thank you so much for your time.
Muchas gracias, Rodrigo.
Thank you very much, Rodrigo.
Muchas gracias a todos.
Thanks, everyone.
Estamos
And
pasados en el
we
tiempo.
are a
En
bit
China ya es muy
past the
tarde.
time. It is very, very late in China now.
Quisiera solamente hacer
And I would just like
algunas
to
conclusiones, porque nos vamos ahí a
make some
algunas preguntas
conclusions
sobre
now,
distintos temas
because we
de
have some questions
sustentabilidad,
regarding different
hidrógeno,
sustainability
etcétera,
issues
pero
and hydrogen,
no nos
etc.
vamos a alcanzar a
But
esto. Simplemente
we
quiero
are not going to be
decir
able
que
to have questions. But
lo
I
que
would just like to say,
quisimos hoy día poner
what
en
we wanted to do
contacto
here
académicos
is just to put
chinos y académicos
members of the academia from
latinoamericanos
Chile,
para
Latin America,
analizar
and
el
China in
desarrollo
contact so we can analyze
sostenible.
the
El
sustainable
desarrollo
development.
sostenible
Sustainable
visto desde
development
distintos
seen from
puntos de vista,
different
desde lo
points
que
of view,
pudimos
from what
analizar
we could
en
analyze
China,
in
los
China
académicos,
and
el
the members of the
hidrógeno,
academia,
la
hydrogen,
colaboración
the
productiva,
collaboration,
etcétera.
productive collaboration,
Queremos
etc.
que estas
So
actividades
we
de
would
la
like that
Fundación
these
CLEC
activities
sean
of the
un
Clegg
acercamiento
Foundation
entre los
are
profesores
a bridge
chinos y
among
latinoamericanos, que
professors from
generemos los
China and Latin
contactos.
America so we can get
Estos
connected.
seminarios, al igual que
And
los
these
otros,
seminars,
quedarán
just like the
en
other
nuestro canal
seminars,
de YouTube
is going to be
y
in our
podrán
YouTube channel. So
verlos,
you can
transmitirlos,
always
etcétera,
watch
y
it and
nosotros
broadcast
servir
and
de
stream
nexo
them,
también
and we can be
entre los
also
académicos.
a link
Así
among the
que
members of the
muchas
academia.
gracias a
So
todos.
thank you
Los
so much,
invito
everyone. I would like to
además
invite you
para en
also
agosto ver un
in
tema muy
August so we can
interesante
see a very
igual
interesting
que
topic
será el
that we
chino
have, which
más
is going to be
derecho, en que
Chinese plus
analizaremos
law,
las
where we analyze
regulaciones
the regulations,
cambiarias, las regulaciones de
the exchange
contratos en
regulations, the
China
contract
acá, la
regulations in
creación de
China,
empresas en
and the
China y
creation
en
of
América
companies in
Latina,
China
cómo vincular
and
todos los
Latin
aspectos
America, how to
legales
link all
para
of the legal
la
aspects
realización de
for
negocios
making businesses between China and
Así
Latin
que
America.
muchas gracias a todos
So thanks everyone,
un
and
abrazo especial
big
a
hug
China
everyone
y
to
a los
China
amigos de Chile
and
y
to all of our
agradecer
friends
sobre
from
todo
Chile.
a los
And we'd like to
intérpretes.
thank especially to our
Muchas
interpreters.
gracias también a
Thanks as well
Xiaoxi,
to
muchas gracias a
Xiaoxi,
Ramiro,
to
muchas
Ramiro.
gracias a
Thanks,
Yasmín. Quiero
Hasmin.
agradecer a
I would
los
like to also
profesores,
thank
a
the
Wan Yu, que está en
professors,
Chile
Wan
también, que ha
Yu, who's in
traducido al
China as
inglés,
well,
a
and he's also
Francisco,
going into English, and
Rodrigo,
Francisco,
profesor
Rodrigo,
Ku Ji-yun,
Professor
profesor
Ku
Shun Luo, que
Eun,
estaba en
Professor
Corea. Ha
Shulo,
sido
who is in
bastante
Korea. It has been
internacional
very international
nuestro
today,
seminario.
all of our
Xiaoxi,
seminar.
que está
And
en
Xiaoxi,
España,
who is in
Ramiro, que está
Spain,
en
and
Londres,
Ramiro, who is in London.
para que demostrar un poco
And
también
so we
que
can
las
show a little
tecnologías
bit
nos
that
ponen en
technologies
contacto, no
put us
importando las
in
distancias.
touch
Muchas
regardless of distance.
gracias.
Thank you
Adiós.
so much, and bye bye.